In this section, we are in section 2, problem 1. So you need to know that you are not allowed to use a calculator. So if you look, there will not be the button for it. The question itself seems pretty straightforward. It says what numbers are rational. But of course, if you have any hopes of doing this, you need to know a lot of vocab. So my goal for this video is to teach you some of the vocab so that you're able to figure out what a rational number is, and then the directions say select the numbers you want to choose, which is the state's way of telling us that we need to pick all of the answers that apply. So we're looking for all answers that are rational, so there's probably going to be more than one answer. First off, when we're looking at what a rational number is, really, numbers can be divided into two categories. There's a couple more, but for the purposes of this video, we only worry about rational and irrational numbers. I'll show you what an irrational number is first because there's less numbers to worry about with those. So irrational numbers are numbers that really aren't usual numbers, like pi. Pi is an unusual number because it's 3.1415, and the decimals keep going on and on and on and on forever. So irrational numbers are numbers that never have an ending point. So pi never ends. Other ones that you might see are most square roots that you'll come across are irrational. Like the square root of 5 is irrational. If I try to take the decimal of that on my calculator, and you can do this along with too when you're doing the test, if you did the square root of 5, you'll see that it's a decimal, so 2.23606, and then the decimal, even though on your calculator it looks like it ends, it actually doesn't. So the square root of 10 is also an irrational number. If you did it on your calculator, you'd get a decimal that would just keep on going on and on and on and on. So not every single square root would be an irrational number. For example, the square root of 9 is not irrational because the square root of 9 is equal to 3. 3 times 3 is equal to 9. So because the number ends, it's not an irrational number. So really a great memory trick here is if you see a square root, it's going to be irrational unless the number that's under the square root sign is a perfect square. Those numbers are like 4 because 2 times 2 is equal to 4. 3 times 3 is equal to 9. 4 times 4 is equal to 16. 5 times 5 is equal to 25. So the list continues. 6 times 6 is 36. If you see any of these numbers underneath the square root, then it would not be irrational. It would actually be a rational number. So just looking at the question here, we can already eliminate a couple options. So you'll use your option eliminator, and we can see, we already talked about, we're looking for rational numbers. Well, just by talking about what an irrational number is, we know that this pi cannot be an answer because pi is irrational. It never ends. The decimal never ends. And the square root of 5 is an irrational number because when you do that on your calculator, you get a decimal that would never end. Also noticing that the 5 is not a perfect square. So it's going to be an irrational number. Now we'll have to look more carefully at the other ones because those may or may not be rational numbers. So let's look at what a rational number is. First off, when we look at rational numbers, we can see that they're actually going to be divided into a lot of different subgroups. These are words that you've heard before, you've taken notes on, but sometimes they get confusing and you forget what each one means. The first subgroup is natural numbers. A natural number, I like to think of as kind of things that you'd see more in nature. So in nature, you more count things as ones, twos, threes. So that's what the first one would be, is a natural number is 1, 2, 3, 4. Some numbers that are not natural numbers, negative numbers are not natural numbers, and 0 is not a natural number. So really there's no decimals, it's just 1, 2, 3, 4, 5, 6, 7, and so on. The next group is a whole number. Really, a whole number is the same thing as all of the natural numbers. So notice this part here, these are just natural numbers. The only thing that's added with whole numbers is now we include 0. So really, the nice thing about these rational numbers is the groups just get bigger and bigger and bigger, but they still include everything that came before it. So now we have 0, 1, 2, 3, 4. The next group is called integers. Integers are obviously what we had above it, so 0, 1, 2, 3, and 4, but now what's added with the integers is all of the negative numbers as well. So the definition of an integer is the whole numbers and their opposites. So we get negatives, and we get 0, and we get all positives. But notice, we still don't have any decimals or fractions or anything like that. It's just negatives, 0, and positives. So if you see in your classroom the number line, really that could be called an integer line because there's negatives and 0 and positives. When we move a little bit bigger groups, the only things that you don't see now that we have negatives and zeros and positives, now you're missing the fractions and the decimals. So those are called rational numbers. So anytime you see fractions, those would be rational numbers. Anytime you see decimals, so let me move this page down a little bit, decimals that end, so if you see that it's like 0.5 and then it's done, that's a decimal that ends, or 3.724, or negative 8.26749. All of those have ending points, so those are considered rational. And sometimes they don't end, but they're still rational. And an example of that would be any decimal that you see that repeats, like 3.7 repeating, negative 4.6363, and this line over the top means that that 6,3 is going to continue on forever. So it'll be 6,3 again, 6,3 again, and it'll keep going forever. So there's no end to that. So if you ever see a pattern in the decimal, or like this right here, this line means that the 7 is going to continue on forever. So anytime you see that pattern, it's going to be a rational number. And the nice thing is, all of these numbers here in this list, not there, all of these numbers here are considered rational. So if you see anything that's just a 1, 2, 3, 4, or a 0, or negatives, or fractions, or decimals that end, or decimals that repeat, all of those are rational. The only things that aren't, like we talked about, are pi, because that decimal keeps on going forever, and then square roots of numbers that aren't perfect squares. Because if you type the square root on your calculator, you'll see that it's a decimal, and you may or may not know this. The calculator looks like the decimal ends, but it actually doesn't. It continues on forever and ever and ever. So as long as you know what an irrational number is, I suppose you can just logically say then all of the other things are rational. So going back to the question, it says what numbers do you want to choose? Well, we're going to choose everything that's rational. So this one has more than one answer. First off, 2.0. Well, looking at it in our rational column, 2.0 is really right here, 2. And also, if we look at this, 2.0 is just a decimal that ends. It's because there's an ending point, the point 0. So we know that 2.0 is rational, so I'll select that one. 1 7/8 is the next problem. Well, that looks to be like a fraction to me. And remember back to our list here, any fraction is also a rational number. So we're going to say that 1 7/8 is also a solution because it's rational. And the last one here, maybe a little bit tricky, that decimal has a repeating sign over it, and any number that has a repeating sign, you can see down here, is going to be a decimal that repeats, which means it is rational as well. So this one has 3 correct answers. So you have to make sure you select them all, because if you don't, you'll get the question wrong on the MCA test. So what I would recommend for you, if you want to do well on this, it's probably a good idea to take some time to figure out and study these words again, all of the rational numbers, the natural, the whole, the integer, and the rational. And they're confusing until you take some time to figure it out, and then figure out what an irrational number is, because I guarantee there will be problems very similar to this on the MCA test where you'll need to know that vocab.